Hello and welcome to our webinar about optimization utilizing discrete event simulation. My name is Christian Nigischer. I am Area Manager of Area 1 Digital Engineering at the Austrian Center for Digital Production. If you are not familiar with the CDP yet, please feel free to watch our introduction video and other videos of our webinar series. This webinar is meant for managers and practitioners of manufacturing companies of all sizes, as well as logistics planners and operators independently from the industrial sector. The first part of this webinar will cover the following topics. We will have a short look at the main characteristics of discrete event simulation, followed by the basic components needed for DES modeling. Finally, some areas of application are mentioned. In general, a computer simulation is a model-based imitation of a real system to be able to investigate the system characteristics and behavior, without the need for a physical prototype or the real system itself. Discrete event simulation is a specific type of simulation that models a system with a sequence of events over time, usually including factors of uncertainty and randomness. If we have a look at the main characteristics describing different simulation types, DES is a dynamic, discrete time and usually stochastic simulation process. Dynamic because changes over time are observed, in contrast to static simulations where outputs are not a function of time. Discrete time because variables only change at specific points in time, not continuously over time. Stochastic because in most cases DES models include at least some kind of randomness, and therefore the outcome is not entirely predictable. Furthermore, discrete event simulation, as the name already suggests, is event-based. This means that new system states are only evaluated at triggering events that cause state transitions, while continuous time simulations, usually discretized for digital computer application, evaluate a new system state after each tiny time step. Because of this time-skipping approach, the necessary computation power for DES is relatively low. In simulations that use deterministic models, the outputs are exactly the same for each simulation run with an identical set of input parameters. So the outcome is entirely predictable. In stochastic simulations like DES, at least some input parameters are described by probability distributions. Therefore, the outputs vary with each simulation run. If a sufficient amount of simulation runs is performed, the output characteristics can be estimated statistically. So what do we need to conduct a discrete event simulation? First, we have to create our DES model by defining inputs like events, available resources, or initial states. The model logic that defines the behavior of the model during its execution, and output variables that shall be monitored and presented in statistics, diagrams, or dashboards. All the definitions and modeling is usually done directly in a DES software tool, which functions as a runtime environment for model execution, providing essential functionality like clock management for virtual simulation time, event lists for occurred and pending events, traceability of model states and state transitions, model visualization, and random number generation. Many DES tools also provide additional functionality, like modeling libraries to ease reuse of frequently used modeling elements, code editors for customized extensions, interfaces for communication with other software applications, standardized statistical calculation functions, and a lot more. So where DES can be used beneficially? Everywhere where complex processes are clearly defined by triggering events. Usually, multiple different entities like machines, queues, human operators, transport vehicles, and so forth are involved. Currently, DES is widely used for 3 areas of application. In manufacturing process optimizations like material flow analysis and layout optimizations, in logistics and warehousing optimizations, and for patient flow and layout planning of healthcare institutions. So that's all for now. Thanks for watching the first part, and I hope you will join us for the second part, where we will have a look at DES software tool FlexSim and some project examples. Visit us on social media for more content of our webinar series and stay tuned for upcoming videos. See you soon.